Okay. Couple questions. Sorry. What if I asked you to find that? What would you do? Yes. Punch it into your calculator, and you'll get this long decimal answer, and you can round it to a couple of decimal points. So what do you get? Give me 4 decimal points. Hang on, 0.707. Okay. That's something new. We've never done angles greater than 90 degrees, but you'd still use your calculator, and I'm assuming you get -1. Okay. Back up here, do the square root of 2 divide 2 on your calculator. Square root of 2 divide 2. Square root of 2 divide 2. No, it is not 1.
Oh, 0.7.
Oh, it's the same thing. So this equals this exactly, and this if we punch it into a calculator and round it. Okay? We are going to focus on finding certain trig ratios of certain angles and express them exactly without using a calculator. And common angles include like 30 degrees, 45 degrees, 60 degrees, 90 degrees, okay? And what we're also going to do is we're going to start to go past angles that are 90 degrees. Because angles can, I mean, you can have an angle that measures like that. Something like that would be around 225 degrees. Because if you go halfway, it's 180 degrees and maybe another 40, so it's about 225 degrees. That's something we haven't done yet. Okay? We have not done any trig involving angles greater than 90 degrees. That's what we're going to start doing now for the rest of this unit. And so what we'll be able to do afterwards, okay, is we'll be able to find the sine, cosine, tan of certain angles exactly without using a calculator. And we will also be able to find ones past 90 degrees exactly. Okay? Now, another thing. Right now, you guys have done some trig equations where you've been asked to find an angle. How would you find the angle? Sine inverse, right? You take the sine inverse of both sides. And I'm thinking you're going to get 30 degrees when you do that on your calculator. Oh, on my cross. Well, that's another thing we're going to do. Okay? We can solve certain trig equations where we don't need a calculator to help us find the answer. There are certain angles that have certain values that we're going to look at. And then the other thing is, this is not the only answer anymore. There is another answer. It just doesn't appear on your calculator. Do the sine of 150 degrees on your calculator.
0.5.
It's the same thing. So that means this trig equation actually has 2 answers. 30 degrees will work. Sine 30 is 1/2, and sine 150 is 1/2. Okay? That's something else we're going to look at. So what we're going to be working towards, the point I'm trying to make, is doing trig with angles past 90 degrees and finding certain trig ratios exactly and solving certain trig equations without the use of a calculator. Okay? The first couple of lessons, we're going to work up to it. Okay? We've got to learn some stuff first before we actually jump into these. And the first thing we're going to talk about today is like how do we how do we deal with angles greater than 90 degrees? Well, actually what we do is we use a coordinate grid to help us. Because a coordinate grid, we can plot an angle or we can draw an angle any measure. Okay? So I can draw an angle on a coordinate grid, any measure. And when I draw that angle, I basically said that I've drawn the angle in standard position. So the first thing we need to look at is angles in standard position using a coordinate grid. We're not just going to draw them freehand. So how do we draw an angle on a coordinate grid? Well, an angle is made up of two arms, right? So normally what we do is like, usually angles are drawn so that one of the arms is horizontal, right? And then we measure the angle from here to here in a counterclockwise measure. So this, I mean, what, approximately 40 degrees or something if we used a protractor. And we could get the angle. But how do we put this on here? Okay. The first arm, the arm where we start measuring from, we call that the initial arm. Okay. So the initial arm is on the positive x-axis. And starts at 0. Or sorry, starts at the 0, 0. So whenever we're drawing an angle on a coordinate grid, one of our arms will always be here on the positive x-axis, always. And then we'll continue with the ones below. Okay. All right. Now the other arm, where the measurement ends, is called the terminal arm. Okay. And the terminal arm, well, it depends on the angle that we're drawing. Like if we're drawing a 45-degree angle, we probably don't draw this. Sorry. We probably draw it somewhere around there. That looks like it's about 45 degrees. If we were drawing an angle bigger than 90, let's say we were drawing 100 degrees, well, 90 degrees is straight up, so 100 degrees would be somewhere around there. Its arm ends in a different quadrant. Okay? So the terminal arm it also starts at the origin. Oops. The terminal arm extends into one of the quadrants. Just remember, there's 4 quadrants on the coordinate grid. It all depends on the angle. Okay? So let's look at all the quadrants. Remember, we label quadrants starting in the upper right and then counterclockwise. So we've got 1, 2, 3, 4. Okay? So let's draw an angle in quadrant 1. So I'm just going to make sure that this goes somewhere in quadrant 1. Okay. So remember, this is the terminal arm. Sorry, this is the initial. It always stays where it is, the positive x-axis. This is the terminal arm. And it goes into one of the quadrants, depending on what angle we're shooting. And then we measure the angle from the initial arm to the terminal arm. And we usually refer to an angle when we're drawing on a coordinate grid. We give it a name called this. It's a 0 with a bar through it. And that is the Greek letter theta. Okay. What angles could I draw in quadrant 1? Anywhere from where to where in quadrant 1? Well, what if I draw an angle like over here? What's the measure? 0. And then up to here? 90. So in quadrant 1, I can draw an angle anywhere between 0 and 90. So in quadrant 1, theta is between 0 degrees and 90 degrees. 0 degrees is right on a quadrant, so is 90 degrees. We'll talk about those later. That's why I use the word between. Okay. So what about quadrant 2? Well, in quadrant 2, my terminal arm will go somewhere in here. So I'll just do that. And then my angle, called theta, goes from the initial to the terminal. What are the angles I could draw in quadrant 2? Anywhere between, not 0, 0 is quadrant 1.
90.
Starting from 90, not including, all the way to 180. So theta is between 90 and 180. And you can see the pattern we're going to continue with quadrants 3 and 4, which are down below. So here in quadrant 3, here's the initial arm, always the same. Terminal arm goes somewhere in quadrant 3. And then I measure my angle from the initial to the terminal, and that's called theta. What are the possible angle measures I could draw in quadrant 3? Anywhere between 180 and 270. Good. Finally, in quadrant 4, initial arm. My terminal arm goes somewhere in quadrant 4, and then my angle theta would look something like that in quadrant 4. And I could draw any angle between what and what?
270.
270 and 360. So theta is between 270 degrees and 360 degrees. So that's the first step, is to be able to draw angles of any size, any measure, using a coordinate grid. That's the first step. Okay. The second step every angle that we draw using a coordinate grid, doesn't matter if it's quadrant 1, quadrant 2, quadrant 3, quadrant 4, okay? It has what's called a corresponding reference angle. And that reference angle is the angle between the terminal arm of theta and the nearest x-axis, positive or negative. So before I do quadrant 1, because quadrant 1, I'll do quadrant 2 because I think it'll make a little bit more sense to you if I do this one first. So let's draw an angle in standard position in quadrant 2. Initial arm, terminal arm, there's theta. According to the definition I just wrote for a reference angle, where is the reference angle? So it's this arm as well, and then the nearest x-axis, which is this one, not this one. So this is the reference angle. And how do we denote it, or what notation do we use? Theta, and then capital R. So the reference angle, theta R, is always going to be an acute angle. It's always going to be between 0 and 90. Okay? And we'll see that when we draw them in the different quadrants. Is always between 0 and 90 degrees. 0 degrees and 90 degrees. What do you notice about in quadrant 2, theta and theta R? If I add them together, what will I get? 180. So that means if I give you this, you can find me this. If I give you this, you can find me this. How do you find in quadrant 2? How do you find theta R? How do you find this? Well, you got to take 180 minus theta, right? So if I told you what theta was, you could tell me what theta R is. And it works the other way. If I tell you what theta R is, you can tell me what theta is by doing the same thing. 180 minus the reference angle. So like if I said this was 100 degrees, what would this be? 80. If I said this was 50 degrees, what would this be? 1/3. Okay, you can see how you find it. It's pretty straightforward. Now I'll show you quadrant 1. Because quadrant one, okay, this is one of those things in math where you guys will think it's so easy, I'm going to make it as complicated as possible. Let's draw an angle in quadrant 1. Try not to overthink. Where's the reference angle? Remember the definition. It's from the terminal arm of theta to the nearest x-axis. What's that? Exactly. They're exactly the same. In quadrant 1, because remember that a reference angle has to be between 0 and 90 degrees. Any angle we draw in quadrant 1 has to be between 0 and 90 degrees. So they're the same thing. So if I give you theta in quadrant 1 and ask you to find theta r, it's the same. If I give you theta r and ask you to find what theta is, it's the same angle. Okay, quadrant 3. First of all, let's draw an angle that terminates in quadrant 3. That's another phrase we can use, like so. Where's its reference angle? Well, terminal arm. And is it this one or this one? Left or right? Left. So notice this one, theta r is part of theta. If I told you what theta was, how would you find theta r? Like, okay, let's think of an angle that's in quadrant 3, 200 degrees. So I said this was 200 degrees. What's this? No, it has nothing to do with this. This is 200. We know how much this is. How much is it halfway? 180. So if this is 200 and this is 180, isn't that the difference? So it would be whatever theta is minus 180 degrees. Quadrant 3 is a little tricky, but you'll get used to it. What if we work the other way around? I told you what the reference angle is, and you have to tell me what theta is. So let's say I said this was 50. Yeah, we take this, 50, plus 180 gives us all of theta. So it'll be theta plus 180, or sorry, theta r plus 180. And finally, in quadrant 4. So let's draw an angle that ends or terminates in quadrant 4, an angle between 270 and 360. Where's its reference angle? Terminal arm and to the positive x. Notice in this, like in quadrant 2, the two made 180 together, right? In quadrant 4, the two make 360 together. So if I want to find the reference angle, if I want to find what this is, I have to do 360 minus this portion. So I have to do 360 minus theta. If I want to find theta, and I've given you the reference angle, we do the same thing, 360 minus whatever the reference angle is. Okay. Because we need to understand these ideas of reference angles, because our next step is going to be putting triangles, how to draw triangles in all 4 quadrants. Right triangles, because that's what we do trig with, right? Right triangles. But for now, we're just going to focus on this. So just as a couple of examples, and you can cross out example 2, by the way. You don't, we're not going to do, I keep meaning to take that out, but I forget every year. Okay, so for each of these ones, you have to draw the angle theta, the measure that you're given. You don't have to be exact. We're not going to use a protractor, and that's why it says sketch. Okay? So we have to do three things. We have to put it on the grid. We have to state what quadrant it's in, as in it ends in, and we have to state its reference angle. So all of these, remember, they're all going to start like this. So 160. What quadrant is my terminal arc going to go into? Quadrant 2. Now, where approximately? Like if you think halfway, that would be 45 degrees. Halfway would be 135 degrees, 90 plus 45. But it's more than that, so we got to go lower. So somewhere around there. And it's quadrant 2. Because you guys just answered that question. And what would its reference angle be? 180 minus whatever this is, 160. It's 20 degrees. So we know that this equals 20 degrees. And this one is 160. Okay. 305. Well, let's establish what quadrant. 4. It's going to go somewhere in here. Well, remember, this is 270. All the way around is 360. So halfway into this would be 270 plus 45, which is 315. That would be halfway. So it's going to be a little closer to this, right? Not much. So that would be 315. So I'm going to go just a little bit less than that. And that's theta equals 305. And as you said, it's quadrant 4. And how would we find its reference angle? 360 minus 305, which gives us 55 degrees. Which, when you look at the rest of it, the reference angle portion makes sense. Trustee. Sketch it, state what quadrant it ends in or terminates in, find its reference angle. Okay. So 227, you should get somewhere around there. Because 225 is halfway into this quadrant. 227 will be very, very close to that. So that's 227. That's quadrant 3. And how would I find the reference angle? Theta, or 227 minus 180. Right. 227 minus 180 gives us 47 degrees. Okay. Okay, like I said, we'll skip example 2. And example 3 is just working the other way around. In example 1, you were given theta. In example 2, you're given the reference angle. You're told what quadrant theta ends in, and from that, you find theta. So you may want to sketch. So remember, we've got a reference angle of 58 degrees, so we're kind of drawing an upside down angle like that. So that's the reference angle of 58 degrees. And remember, theta goes from the initial arm, and remember the terminal arm is shared by both theta and the reference angle. So this is what we're trying to find. And how would you find it? Sorry? Yeah, 58. So theta is going to be 58 plus 180. Just going to give us 238 degrees. Try the second one. Now that we did the first one together, I'd like you to do. Okay, so we do this one. Again, you don't have to sketch it. But sometimes it might be easier if you do visualize it. So we've got a reference angle in quadrant 4, which will be something like that. That's about 7. Somewhere around there. Doesn't have to be perfect. And we're trying to find theta, which makes up the remainder of a complete circle. So how would we find it? Minus 71 gives us 289 degrees. Good. Good. Okay. I am going to continue with 4.5 tomorrow. So basically for Monday, Tuesday, and we do have Math Tuesday because it's a Monday schedule. I would like you to do make sure I got this right here. Exercise 4.4 and exercise 4.5, but only these questions. Numbers 1 to 5 and 8. That's, and of course, anytime we have left over, as in today, 20 minutes, and tomorrow, you have time to work on this. Okay.